Here we have a common 3D trim steel from an automotive stamping die. The customer needs a new replacement because it has a section of the trim profile that has broken off during the stamping process. They are either unable to get CAD, or the CAD they have is inaccurate or has not been updated since changes were made to the trim profile. This is where we come in. We will reverse engineer the steel, correct the trim profile, including any damaged, broken, or missing sections. Once we have scanned the damaged steel, we will use that data, along with information gathered from other sources, to create a new CAD model. The new model can then be used in the CNC manufacturing process to make a corrected trim steel. The customer can use the newly made steel to replace the original damaged steel and begin stamping again. The laser scanning process collects approximately 1 million points every 10 seconds. This particular part took about 90 seconds to scan, and it recorded nearly 12 million points in that time. Those points are automatically triangulated on the fly to give the user a visual representation of the real thing, seen here. Next, that raw virtual model has to be altered manually through a series of steps. Notice the holes being removed here, one by one. The broken or missing areas must be filled in using multiple methods to accurately apply correct geometry. Any imperfections, blemishes, or damaged portions will now be smoothed out so the end result will be as exact as possible. After it's been properly corrected, next, the points are used to create 3D NURBS surface geometry. This is required for the CNC tool pathing application. This is generally the most time-consuming step and can be quite painstaking, especially to anyone not very experienced with it. Our team of engineers have decades of combined experience when it comes to these details. They're quick and precise, and at the top of their field. The yellow blanket you see here is the final NURBS surfaces, shown on top of the gray triangles from the original points. Now, let us back up for a moment and take another look at that skin data again. Here is a closer look at the broken portion of the cutting edge that must be replaced when creating the model. Here you can see those triangles being drawn by all the points. Those triangles were shaded to visually present the virtual model. Now you'll see the NURBS surfaces, along with two-dimensional data of the holes and cutouts, all brought together. Each profile, pocket, and hole are virtually cut into the block, using the 3D and 2D geometry, similar to the CNC subtractive machining process. Watch, and you'll see as those details are added back to the model, one at a time. And finally, the end result is a complete, solid CAD model. It's accurate and ready to be manufactured via a CNC mill and a CAD/CAM package. Lastly, let's take a look at a comparison of the original raw scan and the finished model. We can see overall accuracy is within less than just only 2 or 3 thousandths of an inch, or about half the thickness of a human's hair.